Students, now let's proceed with the third question. We have y is equal to 8x upon x cube minus 2x square minus 4x and plus 8. Now, you can observe here, the very first thing that I'll be doing here is factorizing the denominator. You need to get the factors of the denominator. So let's write the question first of all. We have y is equal to 8x, that's a numerator, upon x cube minus of 2x square minus of 4x plus 8. Now, we know we need to first of all perform synthetic division, isn't it? So, let's do synthetic division to get the factors of the denominator. Now, you can observe x cube minus 2x square minus 4x plus 8. I'm going to put x as 1. Let's see what happens if I put x equal to 1. So, I get 1 cube, that's 1, 1 square, that's 1, 4 into 1, that's 4. So, you get 1 minus 2 minus 4 and plus 8. So students, you can observe 8 plus 1 is going to be 9, minus 2 and minus 4 is going to be minus 6. So that's 9 minus 6. The answer is 3. That means the answer is not coming 0. So you can see that 1 is not a root. Can you understand that? 1 is not a root. Let's try for minus 1. So here you put minus 1. So you get minus 1 cube. Isn't it? Minus 1 cube. So minus 1 cube is going to be minus 1. Minus 1 square. Minus 1 square is going to be plus 1. Minus 2 into plus 1 is minus 2. Again, x is taken as what? It is taken as minus 1. Minus 4 into minus 1, you get plus 4 and plus 8, isn't it? So you get now 8 plus 4, that's 12. Minus 2 and minus 1, that's minus 3. So 12 minus 3, the answer is coming 9. That means you can say that minus 1 is not also a factor, isn't it? Here minus 1 is also not a factor. Now, you can check for 2. Let's try 2. Students, 2 cube. 2 cube is 8. So this 8 and this 8, it becomes 16. Then students, 2 square is going to be 4. Minus 2 into 4, that's minus 8. And minus 4 into 2 is also minus 8. So minus 8 and minus 8, it is becoming minus 16. And previously I had plus 16. The answer is coming 0. So can I be very sure from here that one of the root is definitely 2, isn't it? One of the root is 2. Now I need to proceed further to find the other roots. So students, I'm going to make use of the synthetic division. So by synthetic division, I can say the coefficients of the x cube, x square, x, isn't it, from the above equation. So x cube coefficient is 1, x square coefficient is minus 2, x coefficient is minus 4, and the constant is 8. And I know that 2 is going to be the root. So I write 2 over here. Then we know that the 1 comes down as it is. So you get 1 over here. 2 into 1, it is going to be 2. Minus 2 and plus 2, you are going to get 0, isn't it? And then students, this is minus 4. So you get now 0 into 2, that's 0. Minus 4 and 0 becomes minus 4. And students, 2 into minus 4, it is going to be minus 8 plus 8 minus 8. You get the term as 0. Though 0 is a remainder, that means I can definitely say that 2 is one of the root. Then this is your constant. This is x squared. So now I can say the factors are going to be what? X cube minus 2x square minus 4x plus 8 is going to be, what's the first term over here? What's the first root that I've got? 2. So one of my factors is going to be x minus 2. So root is 2, factor becomes x minus 2. We have already seen the concept of synthetic division in our previous questions, isn't it? Further, the second factor is going to come from here. So that's 1x square plus 0x and minus 4. So I get here x square minus 4, isn't it? So now you can easily understand that this x square minus 4 is like a square minus b square. It is going to be a plus b into a minus b. So I get x minus 2 into x square minus 4 is a plus b into a minus b. So x plus 2 into x minus 2. So it ultimately becomes x minus 2 square into x plus 2. So can you observe that x cube minus 2x square minus 4x plus 8 now has what factors? The factors are x minus 2 square and x plus 2. That means our y, students, what can y be now written as? Y can be written as 8x upon x minus 2 the whole square into x plus 2. So now can you see again, x minus 2 is a factor which is repeated 2 number of times, isn't it? So can I proceed further like this? I will take this term 8x upon x minus 2 the whole square into you have x plus 2, isn't it? You want to do partial fraction on this particular term. You can see that the linear factor x minus 2 is repeating, so you need to take this particular type repeated linear factors. You need to make use of the partial fraction. So x minus 2 is repeating how many times? It is repeating 2 times. So I write here a. I'm least concerned about the numerator, whatever is present in the numerator. Students, the only thing that you need to be concerned about is the power of the numerator has to be less than the power of the denominator. When this happens, you can definitely make use of the method of partial fraction. And here, the repeated linear roots concept is going to be used. So the first factor, x minus 2, the second factor, x plus 2. X minus 2 is repeating 2 times, so I write a upon x minus 2 and then plus b upon x minus 2 the whole square plus c upon x plus 2, isn't it? So this is what I am going to simplify, 8x upon x minus 2 square x plus 2. Now don't you recall who's the LCM? The LCM is the term which is present in the denominator. This term is our LCM, so I multiply a upon x minus 2 with the LCM, isn't it? Then I multiply b upon x minus 2 the whole square also with the LCM, and finally I multiply c upon x plus 2 with the LCM. You have seen the procedure, students, isn't it? So now you are well aware of what is going to happen over here. So all the terms are multiplied with the LCM. So what I'm going to get here, so I write first a multiplies with what? So x minus 2, this LCM imagine over here, this entire term is imagined over here. So 1 x minus 2 cancels, 1 x minus 2 cancels, 1 x minus 2 is left. So I write x minus 2 into x plus 2. Then plus b multiplies with. Imagine the same LCM written over here. So this time who cancels? This time the entire x minus 2 the whole square cancels and you will be left with x plus 2. And finally, students, you take the third term c upon x plus 2. This also multiplies with the LCM, which is x minus 2 the whole square into x plus 2. So this time who cancels? This time x plus 2 cancels. So you will be left with x minus 2 the whole square. This entire thing has what denominator? The denominator is your LCM, which is x minus 2 the whole square into x plus 2. This is equal to your left hand side. So I'm just arranging the terms, isn't it? So the left hand side now becomes RHS. It is 8x upon x minus 2 the whole square into x plus 2. So what cancels here from both the sides? You can see that x minus 2 the whole square and x plus 2. This term cancels. You will be left with your equation. So the equation is a into x minus 2 into x plus 2 plus b into x plus 2 plus c into x minus 2 square is equal to 8x. I'm going to call this as my first equation. Now, students, how many factors are present? Remember, there are only 2 factors present. One of them is x minus 2. The second one is x plus 2. So let's utilize these 2 factors. Let's get the 2 constants first of all, and then later on we will worry about the third constant. So at this moment, whatever factors are available with me, I'm going to make use of those factors first. So my first factor is x minus 2. So I'm going to put x minus 2, or you can say x minus 2 anywhere, it's the first factor. So let's put x minus 2 equal to 0. That means x is equal to 2 in your first equation. So wherever you see x minus 2, you are going to put the value as 0. So this is 0. So a into 0, you get a into 0. Then x minus 2 is taken as 0 and x is taken as 2. So if x becomes 2, that's 2 plus 2, you get 4. So you get b into 4 plus c into what's x minus 2 you have taken? It is 0 is equal to 8 into x is taken as 2, so 8 into 2, that's 16. So when you simplify, b is going to come 4, students, isn't it? B has come 4. Let's call this as the first relation. B has come 4. Now, once I've got the value of b, now let's proceed with the second factor. Now, once the factor x minus 2 is over, the second factor is x plus 2. So let's begin with the next factor, x plus 2. So I'm going to put x plus 2 equal to 0. That means x becomes equal to minus 2 in our first equation. So wherever you see x plus 2, there you are going to put 0. So here you see x plus 2, so that becomes a into 0, isn't it? X plus 2 is 0, so a into 0 plus b into, again there is x plus 2, so x plus 2 is again 0, so b into 0 plus c into x plus 2 is 0, so x is minus 2. So when you put x as minus 2 here, you get minus 2 and minus 2, that's minus 4. Minus 4 square is 16. Isn't it? You have got minus 2 and minus 2, that's minus 4, its square is 16. It is equal to 8 into x is taken as minus 2. So 8 into minus 2, you get minus 16. So this time c into 16 is equal to minus 16. That means, students, what is c going to be? It is going to be minus 1. I call this as the second relation. So I've got b equal to 4, I've got c equal to minus 1. Now I can proceed further with the next constant that is left, which is a, but I can observe that all my factors are over. That means the next factor is what I'll be choosing, isn't it? I'll be assuming some value. So I can see that x equal to 0 is not utilized, isn't it? So I'm going to make use of x equal to 0 to obtain the last constant. So I'm going to put x equal to 0 in equation 1. So let's write it over here. So I'm going to put x equal to 0 in equation 1. So let's put x equal to 0 in the first equation. So students, now when I put x equal to 0 in the first equation, what will happen? So if I put x equal to 0, 0 minus 2, that's minus 2, 0 plus 2, that's plus 2, minus 2 into plus 2, that's minus 4. So you get minus 4a, isn't it? I'm putting x as 0. Then x is taken as 0, so 0 plus 2, so that's 2, you get 2b. So you get plus 2b. Then you are putting x as 0. So 0 minus 2. You are left with minus 2. The square of minus 2 is 4. So you get plus 4c is equal to, what is x taken as, students? X is taken as 0. So 8 into 0, you get 0. Now, don't you know the values of b and c? B is 4, c is minus 1. So let's make use of those values. So I can say minus of 4a plus 2 into, what's the value of b? The value of b is 4. So I write here 4 plus 4 into, what's the value of c? The value of c is minus 1. Minus 1 is equal to 0. So that's minus 4a. Isn't it? 4 into 2, that's 8. 8 and minus 4. So 8 and minus 4 is plus 4. This is plus 8. This is minus 4. So 8 minus 4 is going to be plus 4. Plus 4 equal to 0. So 4a becomes equal to 4. So a becomes equal to 1. I'm going to call this as my third relation. So students, I've got the values of a, b and c, isn't it? So now I can go back to this y is equal to 8x upon x minus 2 the whole square into x plus 2. This term is a upon x minus 2 plus b upon x minus 2 square plus c upon x plus 2. You know the values of a, b and c. That means I can now say y becomes equal to what? It is this term, isn't it? 8x upon x minus 2 square into x plus 2. Now you have written it as a upon b upon and c upon. You have the values of a, b and c. Let's utilize them. You get 1 upon, a is 1 upon x minus 2 upon x minus 2, then plus b. The value of b has come 4. So plus 4 upon x minus 2 the whole square. The value of c plus c, it is minus 1. So the plus c becomes now minus 1 upon x plus 2, isn't it? You know the formula for 1 upon ax plus b as well as 1 upon ax plus b raised to m. So I'm going to differentiate n times here. Differentiate n times. So if I differentiate n times, students, what I'll be getting? So I'll be getting yn is equal to, this is 1 upon ax plus b. So 1 upon ax plus b, very simple. 1 upon ax plus b, the nth derivative, the formula is written over here. Make use of that formula. So I get the answer as minus 1 raised to n, a raised to n. So that's 1 raised to n into n factorial upon ax plus b raised to n plus 1 x minus 2 raised to n plus 1. That's the nth derivative of the first term. Be careful with the second term. Now there is a 4 which is a constant term, so I write plus 4 into, the 4 is taken aside, it's a constant term, and then 1 upon x minus 2 the whole square looks like 1 upon ax plus b raised to m. So this time I'm going to make use of the formula directly, students. I'm going to write the step directly. So what I'm going to get, first term is minus 1 raised to n, so minus 1 raised to n. The next term is m plus n minus 1. M is 2 over here, isn't it? You have m as 2. Ax plus b raised to m, the value of m is 2. So 2 plus n minus 1. So that's 2 plus n minus 1 gives me n plus 1. So I write here n plus 1 factorial, isn't it? So I've got n plus 1 factorial, and then a raised to n. Students, what is a raised to n? So a here is 1, so you simply get 1 raised to n whole divided by, what's your denominator? It is going to be m minus 1. So m is 2. So 2 minus 1, that's 1. 1 factorial is going to be 1. So no need to write it. And then ax plus b raised to m plus n. X minus 2 raised to m is 2. So that's 2 plus n, or I better write it as n plus 2. And finally, students, the last term is with a negative sign. So I change it here and write the negative sign. So minus sign, 1 upon x plus 2. Students, what is going to happen to 1 upon x plus 2? Again, the same formula, 1 upon ax plus b. So I'll be getting it as minus 1 raised to n, 1 raised to n upon n factorial upon x. Then you have plus 2 raised to n plus 1. That's your answer for the third question. Now students, in the exact same manner you can solve the fifth and the sixth question. There is absolutely no change while solving the questions 5th and 6th. It is absolutely based on the method that we used in question number 3. Now the question number 4 that you can see, x upon x plus 1 raised to 5. I'm just going to discuss this question. It is a very simple problem. You can easily get your answer. Observe carefully. Can I say this x upon x plus 1 raised to 5, can it be written as x plus 1 minus 1 upon x plus 1 raised to 5? Observe carefully what I have done. In the numerator, I have brought a plus 1 and a minus 1. Now, what this has changed the terms into? Can you see that the term present in the numerator x plus 1 was nothing but the denominator itself? X plus 1, numerator also now has x plus 1. Can you now separate the terms? Let's separate the terms. So x plus 1 upon x plus 1 raised to 5. One of the x plus 1 will cancel and you'll be left with 1 upon x plus 1 raised to 4. The next term is going to be minus 1 upon x plus 1 raised to 5. So both the terms look like 1 upon ax plus b raised to m. For the first term, m is 4. For the second term, m is 5, isn't it? So you can now very easily make use of the formula directly. So the fourth question is a very simple question. So this is what has concluded our type 5 students. So in this entire session, what things we have learned? We have learned what is the method of partial fraction. The 3 types of questions we have learned. When the power of the numerator is less than the power of denominator, partial fraction. When it is equal, we do the arrangement and then partial fraction. When it is more, we do polynomial division and then we do partial fraction. And in this type, when you have repeated linear factors, the only thing that changes is the arrangement of the constants. A upon the first linear factor, then plus b upon the square of it, then the c upon cube of it, and so on. It will keep on proceeding till the highest power, isn't it? So this is the only change you can see in repeated linear factors. So students, I'm very sure that you have understood all these types of questions very properly. Now we are going to proceed ahead with some other type of questions where trigonometric formulas will be involved. So students, let's proceed ahead.